Hi everyone, very warm welcome to you on DPS 2022. Today we are going to deliver a session which is about scale out read workloads with Azure SQL DB Hyperscale, and the feature is called as named replica. My name is Balmukund and I'm working as a product manager with Azure SQL database team, and I specialize in Hyperscale. Over to you, Attinder.
Thanks, Balmukund. Hello, everyone. My name is Attinder Singh. I also work as a product manager with Azure SQL database team, and primarily focusing on Hyperscale. So prior to this role, I was part of Microsoft field engineering team, where I got opportunity to work on optimization of load of solutions across various industries and verticals. So let's go through the agenda for today. So we will be discussing today about a hyperscale overview, so that that will be our basics for the named replica. As named replica is a feature that is present only in a hyperscale tier, and then we will be focusing on or through the read replicas that we have and what are their use cases, and then we'll go to named replicas feature. Its capabilities, and some cool demos. All right, so before we jump to the named replicas, let's first discuss about the hyperscale. So hyperscale actually utilizes the same SQL server that we have been using in our on-premises or cloud world from decades. So the difference in hyperscale is its distributed and scaled out architecture that separates storage and the compute layer. So like, for example, in on-premises world, we used to have CPU, memory, disk containing transaction log files and data files, all the components in a single physical or a virtual machine, right? However, that had a lot of challenges associated with it, like how to handle hybrid analytical workloads. What if database grows exponentially? The complexity to scale up or even scale out of resources. How to handle modern architectures and the manageability of resources if new application need to be plugged in to the existing solution. Or maybe to feed data to a new target system like Power BI, analysis services, etc. And then as and when your database size grows, how to manage your database backup and restore times, because those times will also grow exponentially if you take the database backups or even for that matter restores, right? So all these challenges that we had are actually mitigated by hyperscale here, and it adds up new capabilities to the relational database world. So additionally, hyperscale also removes practical limits that were imposed in cloud databases, like limited resources in a single node, right? So those limits are not imposed in hyperscale tier. Again, hyperscale is no different. It is like the developers follow design practices, and the DBAs leverage same or the traditional tuning practice to optimize their databases. All right, so moving on to the hyperscale architecture. So since as you can see in the architecture, let me get my pen quickly. So as you can see in the architecture, the compute and the storage. So this is the compute layer we are showing here. This is the compute layer, and then this is the storage layer. So this compute and the storage layer are decoupled in this architecture. So since storage is separated from compute, the compute has a non-covering SSD cache, which is highlighted in yellow, the light yellow color, in addition to the SQL Server memory or the buffer pool that we are aware of, right? So, and this SSD cache that we see here is actually 3 times the memory that we get or that is allocated if while provisioning of a vCourse, like let's say we provision 10 vCores, then based on that, the amount of buffer pool that will be associated. And then this SSD cache, that is the local non-covering SSD cache, we call it, is actually the 3 times the memory, right? So purpose is so that the hot data can be cached in compute node itself to reduce the IOPS to the page servers, right? So this round trips can be reduced to enhance read performance, right? So, and the size of memory depends on the vCores that we have already discussed based on the database vCores that we have provisioned, right? So now this coming to the log service, this log service is also externalized. Write request land on the primary replica, and then these log records follow the same val protocol, that is a write ahead logging, which pushes the log records to the log service. Log service is then responsible to push the log records to the respective page servers, which requires the changes or which for which the change is made. And then this log service at the same time is responsible to feed the log records to all the secondary replicas, that is the read replicas that we have, that is high availability secondary replica, and even the named replicas, and even the geo replicas, right? So this log service is actually catering or serving the log records to all the replicas plus the storage layer as well, okay? Now, coming to the page servers, these are paired page servers. Paired, if you see in the figure in the diagram, it says a resilient copy of a page server, right? So this is like 128 gigs each. So these are fully covering SSD cache that is shown in or highlighted in a dark yellow color. It says meaning the complete data is or resides in this SSD cache of the page servers. So these page servers are actually powered by the SSD cache, and the page servers are zone redundant, or they are aware of if, let's say, hyperscale is provisioned as zone redundant, that means these page servers gets placed or are aware of the different availability zone. And in case any disaster happens on the, let's say, primary availability zone, then we already have a complete setup on the different availability zone, so that can be picked up automatically without any manual intervention. So your traffic or the requests will automatically be landing to the different availability zone in case anything happens to the primary availability zone. Basically, this, if you also see like these, both the page servers, right, they're hot copies, meaning they can serve read requests if one of the page server is busy. Let's say primary compute is pushing massive amount of data to this page server, and then let's say secondary compute, that is a read replica, requests for the data, and it sees that, okay, primary page server is busy, then it can, the secondary page server, which is always in sync, can always feed the data to the secondary copies. Can be named replica or even Azure replicas. So these are both hot at any given point of time, and they both can serve simultaneously to the to all the compute layers. Right. So coming to the data files, so the data files are kept in the Azure storage, which will be utilized for taking snapshots. And if you see, each page server and data file, I mean, each page server is mapped with a data file. So you are aware of a data file is like the .ndf files, MDF or NDF files on the on-premises world, right? So this 128 gigs page server is actually mapped to a data file. And then this data file will be, the snapshot of this data file will be taken, which actually, you know, earlier we used to be used to take the native backups, that is backup and restore backup database using backup database command. Now we are taking a snapshot level backup, so that the challenge that we had of long backups and long restores can be mitigated. And these snapshots, if we restore a database, can be very, very fast, right? So Now coming to the secondary replicas. So we can have 0 to 4 of HA replicas that we see here. And then we can have up to 30 named replicas. So this HA secondary replica is for the high availability purposes and to improve the SLA to 99.99%. Right. So, and then geo replicas are also available and they are generally available for the disaster recovery purposes. Right. So in case any disaster happens in a region, you can always manually fail over your database to the geo location, right? And another advantage is like, for example, I mean, even if you have provisioned a very small primary compute, let's say 4 vCores, we are not limiting the log throughput. So log throughput is 100 MB per second, no matter what service level objective that you choose. Right. So this is the architecture, and now what we will do is we will go further to discuss more about the hyperscale secondary replicas. So Balmukund, as I've explained that we have HA secondary replica, we have named replica, we have geo replica. Could you highlight like when to use or when to utilize or when to provision high availability secondary replica or named replica or geo replica?
Sure. Thanks, Ananda. Just to add, I think you missed one point in the last slide, is that the database size, we support up to 100 terabyte database size. Yeah. And the reason we are able to achieve that is because of the distributed storage, what we have, what are there. So as and when you ask for, you increase the database size, we keep on adding more and more page server. So that's how we are able to provide you the storage of the database up to 100 terabyte as of today. Limit might change; they are not the hard limit, but that is a supported value as of now. Just to highlight that, since that was missed in the last slide. Anyway, so yeah. Now coming back to the secondary replicas. So as Attinder showed in the previous slide, there are various type of secondary replicas available. If you recall, the one which is just near to the primary compute was called as HA replica, or it is called as high availability secondary replica. You can have up to 4 HA replicas, and as the name suggests, they are for high availability purpose of the primary compute. So they are the hot standby. In case something goes wrong with the primary, within few seconds, a failover will happen, and the HA replica would become the primary replica, and the application will start getting the data from that particular compute, which became primary after failover. Another thing is, if you do not have HA replica, it is not mandatory to have HA replica, but only problem you would see is that once the primary has to go down, Azure infrastructure will take a little bit of time to provision a new compute and attach the page servers there. So that impacts the SLA. That's why these are very hot standby. As soon as the primary compute goes down, HA replica would take over. So that is the HA replica. Now, you may not want to waste the resource what you have consumed in HA replica. So you can always redirect the read workload to the HA replicas as well. Now, how do you connect to HA replicas? Basically, if you recall always on scenarios, or if you recall business critical tier, you always connect to the endpoint, which is the logical server name, and you provide the database name where you want to connect. And then you provide an additional parameter in the connection string called as application intent is equal to read only. As soon as you tell the intent from the application side, Azure will take care of sending that particular request to the HA replicas, because the endpoint, the server name, and the database name combination remains the same. So that way you can utilize those HA replicas which are provisioned for HA purpose. You can consume them for the readable purpose as well. One thing to keep in mind is, since these are HA replicas, they are of the same vCore size what you have provisioned for the primary compute, which means if your primary compute is 24 vCore, all the HA replica, whatever you provision, will be of 24 vCores only. You cannot change the configuration there. And as the slide says, they are AZ aware, which is availability zone aware. So if you look at the picture, you could see the compute is there on both the zones, AZ1 and AZ2. Log service is also having both in both the zones, which means in case the AZ1 has to go down, AZ2 is already waiting for you to take over everything what is there in the previous zone. So that's what we mean by AZ awareness of hyperscale. So that was about the HA replicas. Now coming to the geo secondary replicas. Now, as you can imagine, you always want to have a disaster recovery strategy in place for the application which are mission critical. Software will fail, hardware will fail. You need to plan for the failures to make sure the business is running most of the time. Geo replicas, as the name suggests, they are geo, which means you can provision a geo secondary in a different region altogether. And the main purpose of them is a disaster recovery. They are not the synchronous copy of the data. They are asynchronous, and they're also AZ aware. Whenever you have to do a failover to the geo secondary, you always have to do a manual failover because they are meant for disaster recovery, not for high availability. For high availability, we use HA replica. For disaster recovery, we use geo replicas. So we have to do a manual failover. Now, since you have a replica sitting there, and if you really want to utilize the power what you have given to secondary geo secondary replica, you can always redirect the application to which is sitting on that zone probably to the geo secondary replica. Since it is a geo secondary, it will have its own endpoint to connect. You will have a server name and which will have the same database name as well. And as I said earlier, they are asynchronous data movement which happens between these two replicas. So these are the two readable secondaries, so to say. One is HA, one is geo. Next slide, please, Attinder. Okay. So next we are going to talk about the named replicas, which is what the meat of the today's presentation is. If you relook at the picture, within a boundary of a compute of the left hand side, you have a primary replica and the HA replica sitting next to it. And as you look at the picture, you will realize there are multiple HA replicas which are 0 to 4. They are of the same size, what I said earlier. Now, coming to the right-hand side box, it again has databases of, as you can see, the various sizes. It essentially denotes that you can have a named replica which are of different compute sizes. You can have 2 vCore, 4 vCore, 20 vCore, 24 vCore, whatever vCore you want to have, up to 80 vCores as of now. And you can rewrite the read workload there, right? So if there's a situation that you want the ingest or the data input to happen on primary, and you want the read workload not to be affecting the primary, you will rewrite that workload to named replicas. And as I said, you can have different compute sizes of the named replica, which means if your application is running an analytical query and you think it is going to benefit from multiple cores available on the database, but you don't want to pay for that on primary compute, you can have a named replica with 80 vCores with the primary compute which is just 4 vCores. That is one of the use case where you will start using different size of the named replicas. As you can see in the picture, they all share the same page server. They all share the log service. A log service is changed. Now it is called as log replica, which is the enhancement which is done the log service. But for now, you can think that is the point of commit where the transaction, once it happens on the primary, has to commit till the log replica, and then it will be propagated further from that point onwards. So they all share the same set of page server, same set of log service, which essentially mean they have to be in the same region. So name replica stays in the same region as primary replica. If you want something on the other region, you have to go with geo replica. Now, these are just you can think of them as a endpoint to connect to a database. The underlying data is still the same, which is served by the primary compute and HA replicas. You can give them a database name, what you like. You can also have the server name, what you like, which means you can have a combination of having the same logical server name as given to primary compute, or you can have a different logical server name altogether, which is maybe resembling the application name. And then you can have a database name, which can really obfuscate the actual database name on the primary compute. So you can have various combination to name the replicas. So the only thing to keep in mind is that database name and server name combination must be unique, right? You can have a altogether different server name or a same logical server name. Now, when you provision the compute or the name replica, as you can see that they are just the compute nodes, right? They just need vCores and they will attach themselves to the log service and the page log replica and the page servers, which means the provision of them is pretty fast because they do not need any data to be copied under them. They just need to be up and then attach themselves to the existing page servers and the log replicas. You can also create name replica on geo secondary. So you may have a situation where you want to have exactly same copy on two regions. So in case you do a disaster recovery, you may want to just do a failover and then everything should become up and running there. Now, you might argue, do you really need to have the name replica up and running there? May or may not be, because as I said, they are pretty fast in terms of spinning. They come up very fast. So you may want to, when you do a DR drill or when you do a disaster recovery procedures, you can have a step which will say, create the name replicas as well. Or if you want, you can have them ready already, right? And as we said, they can serve the request for the application if the primary compute goes down, because they are independent compute nodes attached to the same set of data layer, so to say, log replicas and the page servers. So I think that gives you a gist about what name replica is all about. Now I will let Attinder talk further about various use cases and other things. Attinder, over to you.
Yeah. All right. Thank you. So let me go to a quick demo that you have explained so that we can see in action when we provision the named replicas, or how to provision a named replica. Let me just pull up my screen here. So in order to provision a named replica, first of all, I'll just show you the provisioning part, and then we will come to the use cases that you just mentioned. All right. So in order to provision it, we'll just go to the Azure portal, and then in the Azure portal, we will go to the create resource plate. Under that, you will see create a SQL database. So once you click on create button, so that is when you will get all the options, what you can choose to provision either a general purpose database or a business critical or a DTO model as well. So I've just chosen the resource group created specifically for this demo, that is DPS 2022. We will choose any name for the hyperscale database like DPS HS 2022 DB, and then we can choose either the existing server. We have already provisioned that for DPS, or you can create a new server. Now, you come to the compute and storage layer, wherein you can actually specify which tier that you want to choose. You want to choose general purpose, hyperscale, business critical, DTU. So all these provisioning options that you get here. I'll choose hyperscale on-demand scalable storage here. And on the right side, if you can see, you see that the cost estimation is provided, wherein you get the estimated cost per month and the storage cost per month. And now you can actually choose the number of vCores that you want to provision for your primary compute. And then you also have the option to choose the high availability secondary replicas that Balmukund has just explained for the high availability purposes. And then we can have up to 4 high availability replicas along with the primary compute, right? And now, as Balmukund explained, that these services or components are zone redundant. So that means we can choose this option here. This will actually make all the components as a zone redundant, right? So this way, we just click apply, and then we provision the and just review plus create if you choose. That is when your named hyperscale will be provisioned. Hyperscale database. I'm sorry. All right. So in the interest of time, I've already created this hyperscale database. So let me switch to the another tab. And in this tab, if you see, DPS 2022 database is already created. And this is a hyperscale Gen 5 2 vCores pricing tier database. Now, let's go to the provisioning of named replicas. So there are multiple ways to provision named replicas. One is, of course, portal, and then there are multiple ways like T-SQL, CLI, or PowerShell. So we'll go to that layer as well, like how we can provision some other method as well. So here, if you see in the replicas plate, I just click on create replica. In create replica, I get the option to choose the replica type. I'll pick named replica for now, but you have the option to choose geo replica as well. However, you can choose 30 different named replicas from here. And then the database name will automatically be populated. You can choose your own, whichever name that you want to provision. And then you can either provision it in the same server, or you can create a new server altogether if your application requires isolation, or the maybe the different application teams might want to utilize the database as is, so that you can provision a new server altogether, different server for them. However, the underlying storage that we mentioned, it will remain the same. It is just that the logical server will change. Then it will be fetching the data from the same page servers that we have, or the storage layer that we have, right? So I'm actually creating it in the same server for now. And then compute plus storage, we can select how much compute that we need. So number of vCores that we want to choose. So if you would have noticed here, if I go for increasing the number of, you just see the estimated compute cost. Storage cost is not here, because that is something we are utilizing the same storage as the primary compute, so we are not charging for the storage for the named replicas. And you see the pricing is less, further less, because there is no license cost for named replicas as well. All right. So I just choose the 2 vCores for the demo purposes, and I just click apply. And then we go to review and create. It will give you all the estimations, and then you just hit create button. So this way, it will actually create your named replica. All right. So since we've already since we have created the named replica, now let's go to the home page. And from the home page, I'll show you the named replica which is already provisioned for this demo purposes. And if you see here, this is the primary compute specifically created for primary compute for named replica, which is created for DPS 2022 demo. If you see the replicas now, So it will show you the number of replicas that we have already created. That is the named replicas that are already provisioned. So I already have 3 named replicas which are provisioned from here, from the portal. Now let's go to the Azure Data Studio, and let's create another replica having the similar configuration as the primary compute. So it is just a simple command, that is alter database, the primary replica or the primary compute node, add secondary on server. That is your server name. That is logical server name where you want to create or provision the named replica. With secondary type is equal to named, and then the database name, whichever database that you want to provision. So I'll just hit run, and then so we need to create it in the master context, and then your named replica is ready. So provisioning of named replica, as Balmukund mentioned earlier, is very, very fast because underlying storage is being shared. It is just that we are provisioning the compute, that is compute and memory, and in the background we are linking it with the log replicas. So yeah, this is the quick demo for the named replicas. Let me just also show you one. Let's say I want to, during the peak times, maybe a sale period or maybe end of month processing, I want that my read request will be very, very high. In that situation, I can go to my specific named replica, which is handling that load, and I can scale up that specific named replica, which is independent of the primary compute. I mean, I'm not hindering anything on the primary compute remains same, whatever vCores that we have provisioned, but now we want named replica to be having more compute size, memory, and the local SSD cache that we discussed, which is 3 times the memory. Right, so we can increase this compute the number of vCores for a specific named replica. Just to go to compute plus storage and change the vCores, and then click on apply. That's it. So that way, your scale up happens fast, and then let's say the peak times is over, right? So in that situation, what you can do is you can go ahead and scale down the named replica again to a lower compute size, and then you can end up saving the cost there. And all this is happening without affecting anything on the primary compute or anything on the primary replica. So yeah, so that is it from the provisioning standpoint, and the demo of provisioning the named replicas. So let's move further now. Let's now discuss the use cases of named replicas. So, or when to use the when to choose the named replica, right? So the first point is flexibility. Like for customers who are building cloud-borne applications, or maybe trying to future-proof of the scaling up of space and compute, right? Along with scaling out of workloads for a dynamic requirements. With named replicas, you can actually scale out read workloads to up to 30 read replicas, right? And then the workloads which requires independent scaling that I just showed you of compute, as each replica can be scaled to a different compute size without impacting the primary. The compute size meaning like the service level objective. Example, let's say the primary replica is 32 vCores for e-commerce website. A named replica of, let's say, 40 vCores can be created to power an IoT application, right? So requiring independent read scaling again. Or maybe create a named replica of 16 vCores, which can be utilized by analysts to perform real-time analysis, maybe using Power BI. Right, so different compute sizes can be aligned with different application teams or the application requirements, right? And then comes for the critical workloads, right? So we don't want to incur any impact on the production environment. So with named replicas, you can add or remove named replicas without impacting any primary replicas availability, right? So, and also to cater fast scaling requirements, let's say scale up of existing replicas to cater peak times like end of month processing, sale period, business reporting, etc. And then scale down during the lean business times, right? And then comes the isolation, which is a very beautiful factor of named replicas that you can actually considering the flexibility that cloud provides, there could be multiple applications that might be plugged in into a solution, right? So access to primary to feed data, users can work in isolation on their respective named replica as logins or AD groups can be granted isolated access and dedicated connection endpoint to respective read replica can be created. So some use cases like workload dependent routing, let's say two named replicas serve a request for mobile applications, maybe one dedicated named replica for data science project, and two named replicas for web applications, right? So they all can work in isolation, and the field will be like individual application owner will feel a separate, like have a separate look and feel of our database. Um, we will come to the demo of isolated access as well in a bit, but let's cover the other use cases first, like the cost saving part, right? As I showed in the demo, the cost saving for the read scale out scenarios, like there are multiple opportunities to scale out the read workloads and without any storage cost for named replicas. As this here, same page servers or storage as primary replica, right? So name replica can be scaled down independent of primary replica. Additionally, licensing cost is not applied to name replicas. So you just pay for compute only. And then comes the modern architectures. So modern architectures can serve modern applications architectures like for analytics purposes or workloads. And then named replica can be utilized as a serving layer to an additional service to reduce impact on the primary replica or primary compute, right? So this is something, these are few of the use cases that that are there for the named replicas. Okay, now let me move further and go to a demo for creating the isolated access. All right. So in order to configure the isolated access, there is an article specifically talking about how to configure isolated access with named replicas. So for this article specifically talks for the SQL Server authentication. For SQL Server authentication, what user can do is they can create a login in a master database of primary compute, and then once the login is created, just take out the SID of that specific login that we have just created in the primary. And then once that SID is taken out or that SID is copied, you can disable the login on the primary replica so that the specific user should not be able to connect to the primary compute because we just want the isolated access to a specific name replica. Now, once that login is disabled, you can go ahead and create a user on the primary compute or the primary replica. So once you create this user, it will automatically be pushed to the secondary compute, right? Because the storage there is same. So, and then we just drop the login on the primary replica. Once the login is dropped, user will not be able to log into the primary replica. Now let's create a named replica. So this is the example which shows the creation of named replica using Azure CLI. Once you create or provision the named replica, what you need to do is you just connect to that server or the new logical server, and then create a login using the SID that we have copied from the primary while creating the primary login, primary getting login on the primary compute, right? So once this login is created, you can actually grant access to a specific object to this specific user. So then application user who will be connecting to a dedicated car will only be able to access a specific object. So that is something like where we can grant permission at such a granular level, or we can have the isolated access. So then this article also talks about how to test this connectivity. Now, for the demo purposes, what we will do is let's talk about the AD group or the Azure AD account. We will create the similar isolated access for the Azure AD account, and then we will see how a user can connect to that. So let me pull up my Azure Data Studio. And in the Azure Data Studio, since I've already provisioned the hyperscale and the named replica, and so this server, which is the primary server, this is a different logical server, and we are showing a different logical server, that is server 2, which is also associated with the same hyperscale primary compute. But just to show you the isolated access, we have provisioned a different logical server. And now what we will do is we will follow the same approach that we followed for the SQL Server authentication. However, the only difference is we don't need to copy the SID as we copied in the SQL Server authentication, as that SID is managed by the Azure AD. All right, so this is a quick demo. I will just create, we connected to the primary compute, the primary replica, as you can see here. I'll just create a login for Balmukund Lakhani, and in the master database of the primary compute. Once that login is created, I'll just go ahead and connect to my primary hyperscale database, and then I'll create a user for Balmukund Lakhani using the login list. This is already exists. I have already attempted this demo earlier. So now what I'll do is I'll drop the login from the master database from this primary compute. All right, so that the user Balmukund Lakhani should not be able to access the primary replica. So I'll just quickly drop the login. Now what I'll do is I'll just connect to the second logical server, which contains my read or a named replica, and I'll create a login for Balmukund Lakhani in that. Okay, let me go to this. Oops, something. Let me just go to new query from here, and I'll just create a login in the master database. So once that login is created, what I'll do is I need to grant a specific access to a specific table or an object. So let's say in this database, I have few objects created. So I'll just grant the access, select on dbo.shopping cart to Balmukund Lakhani user from the primary replica or the primary compute. So once this user we will grant the access to dbo.shopping cart to Balmukund Lakhani. So Lakhani should be able to access data or read data from the dbo.shopping cart. So Balmukund, can you share your screen and show us how you are able to connect to server 2 named replica, and how you are not able to connect to the server 1, that is the primary compute?
Sure. Let me know once it is visible.
Yeah, I can see the screen, yes.
All right. So now I share my screen, and I will try to connect to primary replica first, primary compute, and then we will try to connect to the named replica. So if you see, there are a bunch of database in the server in the recent list already. The one which is this without number 2 is primary. This one, which is server 2 at the end is secondary, which is also the named replica database. The database name on the primary compute is NROLTP, whereas on named replica it is NROLTP underscore named replica on a different logical server altogether. So let me try to connect to the primary first, and if everything goes right, I would not be able to connect because, and as you can see, I'm not able to connect to the primary compute, which means I cannot run the query. Now let me try to connect to the secondary or the named replica. And if I double click on that and click on connect, I'm able to connect to the named replica. And then I should be able to see the table on which I have permission. So this is the only table where Attinder gave me the permission to read. I'll just close that for now. And I have some queries written already, which I can use and show where I've landed. So let me increase the font if that helps. So if you look at the server name, okay, it has to go here. Okay, so it is connected to the named replica, which is server 2, as I said earlier. So added server name shows me server 2 here. If I do DB name, what do you expect to see? I'm expecting to see underscore named replica name, and let's confirm. And as you can see, it is the named replica. What was the login I used? The login which I used is my email address. That's my AAD account. And this is the account which Attinder used to give me the permission. And as you can imagine, I would be able to run the select query on the shopping cart. So Attinder, while we're on this page, can you revoke my permission from the primary if you have the query window already open?
Sure. Yeah, let me do it.
So
right
just
away.
do it on the primary, and we will show live effect on the secondary that user will not be able to select the data once it is revoked on the primary. So.
All right. So I have revoked the select permissions. Can you check it now?
Okay. So let's see. And as you can see that now I'm not able to run the select query on the named replica once he removed the permission on the primary replica. And as we said, named replicas are only readable copies. You can't give a permission explicitly on the named replica. It has to flow from the primary compute, and it will go all over the place on all the replicas, geo, named, HA, everywhere, because they are just the read endpoint for the primary compute. So Attinder, good job.
Thank you. All right. So let me share my screen again, and we'll walk you through the next slides. Okay. All right. So after this demo, let's discuss if there is anything different in named replicas, right? So what we want to emphasize here is like monitoring of named replicas is exactly same as you would do for any of the Azure SQL database. So we have same query performance insights, the DMVs that you are familiar with, monitoring using DMVs, SQL Insights, which is in preview in Azure Monitor, and then Azure SQL Analytics, which is also in preview as of today, using Azure Monitor logs. So along with that, there are a lot of enhancements that are coming on the way for named replicas and even for the hyperscale tier. And then comes the named replicas management. As we have shown you you can manage it through the portal. We can do it through the PowerShell, Azure CLI, REST API, T-SQL. So all of these management of named replicas is actually documented in Microsoft Docs. Okay. So with that, let's go for one more demo, which we wanted to show an application to scale out the read workload. Okay, so let me go to that demo real quick. So as you can see in the screen, so we have an open source tool which is called Locust. The aim or the uh, reason for utilizing this tool is that this tool can actually generate a workload for a specific website, which we have already provisioned for this demo purposes. So that website is a web application that we have hosted on Azure, which is here. Let me refresh it once. And then this locus tool will actually generate workload for this web application. And then we can specify the number of users that can, a number of users and the amount of workload that we want to generate, right? So this is the application, and then this demo that we are showing, it actually is present in Azure Samples, which is prepared or developed by Davide. And you can actually download this demo from Azure Samples, and then be comfortable with named replicas and how to scale out the read workloads. Right. So let's do one thing. So what we have done along with this is that I'll just show you. Let me close this as this demo is completed. All right. So, we have for this demo purposes, we have created some tables or the objects. And then there is a API which you can download, of course, from the samples, Azure Samples. So there are two objects for this demo. One is the API scale out replica. So if I run it, so what does this mean is, like in this, we have created a table wherein we can specify or insert the specific database name or the named replica name, and we can tag it with its purpose. So if it is like a generic read, we can mention it generic read, or maybe for Power BI or analytics or reporting, whatever tag we want to keep. So that intention is that this application, the API that we have, that API will refer this table, and then based on that, it can route the workload to a specific name replica. Based on the connection string that the isolated connection string that we can provision for the name replicas. And then we have a shopping cart table, which is being populated by our Locust application to generate a general workload for the e-com site. That is the cart and how users scan the products and all. So this is the sys.dmdb resource stats, just to have a look at how the resources are performing, or how the CPU utilization or the resource utilization is happening on a primary replica, or for that matter, on a named replica, right? And then we have an update statement that we have written here, which says that right now it is disabled state. So right now, what does this mean is that I'm not scaling out my read workload to named replica, but I'm just pushing everything on my primary compute. So my primary compute is someone who is reading and writing, right? So now let's go to the Locust application, and then let's generate some workload. So to generate some workload, we are just starting with 150 users who are actually simultaneously writing or reading the data. And then we will mention the spawn rate as 10 per second. And this is our host application, that is the target for which we want to generate the workload. So let's start spanning or generating the workload. So as the workload is getting generated, you can see the number of users here. And once it reaches 150, we can see, just focus on this column actually. This is like the latency that we have that is being generated if some user puts the data or moves the data to the cart. And then this is something that is get, which is reading the data or scanning through the products, right? So users may not want this latency, right? So this situation can happen during the peak workloads. However, like this replica that we have provisioned is very small. It is just 2 cores for the demo purposes. But then, as you can see, this average latency has increased to even more than 1 second or 1.2 seconds here. Right. So now what we will do is we'll just make a note of this average latency quickly, and then what we will do is we will now add the named replicas to scale out our read workload. So that the load that we are just pushing on the primary compute can be distributed. Right. So let me just stop this workload here, and I'll go to my Data Studio, and then I will enable these named replicas so that I can scale out my workload. All right, so this is updated, and now my API should be able to read that this data from this table and should be able to understand that, yes, I have named replicas where I can offload my workload to. So now let's create same workload again, and then let's spawn the users. So now, as you see, the users are actually increasing to 150, have increased already. And then you can see that the read workload, which was like more than around 1.2 seconds, now it has reduced to a very small number. You can even reduce this number by just scaling up the compute of the named replica so that your peak workload can be catered. Fine, right? So this is the power that you can scale out, or you can future-proof your applications to scale, so that in, let's say, you have provisioned something, or you might encounter a situation where you want to scale out your read workloads to a different secondary replicas. You have that capability in hyperscale tier, and that actually future-proof your solution for the read scale out scenarios. So this is the demo that I had that we wanted to show you. If you see that average latency is still very, very less, considering the amount of vCores that we have provisioned are also very less for the named replicas. And then you can just download this demo and then play around with it. So I'll just stop the workload here and then go back to my presentation one more time. All right, so Balmukund, I'll hand it over to you now to share some customer stories around named replicas.
Thanks, Attinder. By the way, it was a good demo to understand that you can use named replica to scale out your read workload and hence get better performance of the primary compute. So I think in your demo you just had 2 named replica pre-provisioned, and using the update statement you just modified and informed application that now you start building the connection string using those name given and put the workload. That was the scenario, right? Good.
Okay, yes, that is correct. Yeah.
Great. Okay, thanks for that. So just coming back to the customer who are using the named replica feature and in their production workload, a few of them are listed there. Hi-Res Studio. They launched the game, and then they use read capability of the read replica to scale out their read requirement. Other customer is Clearent, BMI, one of the company who I think who is music company. And if you want to read more about these customers, you can always go to customers.microsoft.com and read about their architecture, how they have been successful on using named replica. Next slide, please. Yeah, and there are few more customer, Quest Analytics, Avnet, ClearSale, Big Red Cloud. These all are the other customers who have been using name replicas and Azure SQL database in general, hyperscale tier to run their business workload. Again, more reading can be done at customers.microsoft.com. I think with this, we have come to the end of the session. Hope you have learned something new today. We tried to give a lot of detail in last 1 hour. If any more questions which we could answer, we are there online available. We can answer the question using the chat window. And in case you have any feedback, anything you want to listen more, if you have used name replicas, have a feature request, or anything which you think will make your business run better using Azure SQL DB Hyperscale, please reach out to us. We'll be more than happy to talk to you and understand more scenarios. Thank you very much.
Thank you so much. Thank you for listening to us.